Okay, this is more practice with calculating means and standard deviation and discrete distributions. Again, this is a review video. Once again, this will show up on your probability test for this unit. So a commuter must pass through 5 traffic lights on her way to work. She estimates the probability model for the number of lights she hits as shown below. Calculate the expected value, mean, and standard deviation and variance showing all work. So once again, I'm going to input my data in the stat edit. So I have 0, 1, 2, 3, 4, 5, and then I have the associated probabilities. Please note that when I say the associated probabilities, they also mean that that's your frequency. So my frequencies are L2, my values that could happen are in L1. So I could have as many as 0 lights, or I could hit as many as 5 lights going through this. So I go stat, calc, one variable statistics. My list is an L1. My frequency is an L2. Again, that's the frequency list or probability. And my mean is 2.1, and I end up getting a standard deviation of 1.3, which I wrote here. If I scroll down, never do I see the value 1.69. So in order to get the variance, I'm going to have to square the 1.39. So this just equals 1.3, excuse me, to the second power. All right, so that's how I get that. The first question was, does the above represent a valid probability distribution? Well, to do that, I would need to check and add 0.1, 0.25, 0.30, 0.20, 0.1, and 0.05. When I sum all those up, they do sum to one whole, so that is a valid probability distribution. Why? Because it sums to 1, there's no negative values, and there's no value greater than 1. Then to show my work, though, on a test, if all I did was this, I would not receive credit. So to show my work, once again, I'm going to take the lowest value. Here's my formula. You don't have to write the formula down, but you do have to show this. My lowest value times its associated probability plus the next one times its associated plus the next times this. But you can abbreviate that and just do 0 times 0.1 plus plus the bookends, the highest one, 5 times 0.05. And so our expected value is 2.1. And by the way, I'm going to pull those values off the calculator. I'll use the calculator for my work, but I do have to show my low and high. Then I need to explain what this means. And it means on average, or in the long run, or if we did this multiple times, or if we looked at the entire population. On average, a commuter can expect to have to stop at 2.1 of the 5 red lights. All right. So we expect them to have to stop at 2.1 lights. Now, obviously, I'm not stopping at 2.1 lights. I'm either stopping at 2 or 3 or 4. But we have to say on average, because that is what the average value is. On average, we would expect that. The standard deviation. Please notice the standard deviation is, or this is the variance, is the individual value minus the mean. Well, what was the mean? The mean was 2.1 that we calculated up here. Once again, I don't have to write the formula, but I need to show my work. So calculating my variance would be 0 minus 2.1 squared times the 0.1, 1 minus the 2.1 squared times this associated probability, 2 minus the 2.1 times its associated probability, 3 minus the 2.1 squared times this associated probability, and so on and so forth, and that would give me my variance. The standard deviation, and once again, I could also bookend this, and in bookending this, I would just go 0 minus 2.1 squared times 0.1 plus plus 5 minus 2.1 squared times 0.05. And that would be adequate work shown for the variance. For the standard deviation, it's going to be much the same, except I'm going to need to come back and put it underneath the radical. Right? Please don't forget to put it under the radical if they're finding standard deviation. Okay. All right, the next problem. So first thing off is I go, okay, 0.15 plus 0.3 plus 0.35, that equals 0.8. Well, that's not a valid probability distribution, and the reason why is I'm missing some values. It turns out the probability of it being 8 is 0.2. So now I can go to stat edit, and I'm going to input those values. And we have 2, 4, 6, 8. Because who do we appreciate? Sensei, which is Spensei. 2, enter, 4, enter, 6, enter, 8, enter. 0.15, 0.3, 0.35, 0.2. And when we go stat, calc, one variable statistics, my X list is in L1, my frequencies or probabilities are in L2. I press calculate, and I end up getting 5.2, a standard deviation of 1.39, and then I have to square that to get that value. Once again, to show my work for my expected value, it's going to look like this. 2 times 0.15, expected value is 2 times 0.15 plus dot, 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 plus 8 times 0.2. And remember, the mean is the expected value, all right? So on average, we'd expect 5.2 from this distribution. For my standard deviation, it would look something like this. My lowest value is 2 minus my expected value of 5.2 times the probability associated with that, plus dot, 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 plus. Then look at the largest one, which would be 8 minus 5.2 times its probability of 0.2. And that would be adequate work shown, all right? And once again, remember, to get this, the variance, you have to square as a standard deviation. So I just looked on the calculator and I took 1.39, I squared that, and that gave me my variance. This next problem is a little more challenging. And what we have is an insurance company charges $1,600 for car insurance. The policy specifies the company will pay $3,000 for a minor accident and $10,000 for a major. The probability of having a minor is 0.2 and a major is 0.3. All right, complete the probability table for how much money the insurance company will make on a policy. So really what they said is you could have no accidents, you could have a minor, and you could have a major. The probability of a minor is 0.22. Probability of a major is 0.03, which means the probability you don't have an accident is 0.75, because these two sum together to make 0.25. So 1 minus that is 1. Because remember, these have to sum up to one whole. So there's my frequency. So that's my frequency or my probability. But the question is, how much money do I make? Well, if I don't have an accident, I have to pay out $0. So I make $1,600. If I have a minor accident, I'm collecting $1,600, but I have to pay out $3,000. So I lose $1,400, or the insurance company does. And if it's a major accident, I still only collecting $1,600 in premium, but I'm paying out $10,000, which means I'm losing $8,400. So these would be my X values that would go into L1. All right, so stat edit. Go up and clear these. And so I either make I can make $1,600. I could lose $1,400. Make sure you're using the little negative sign down at the bottom of the calculator. You lose $1,400. I could lose $8,400. The probability that I make $1,600 exactly is 0.75. The probability that I make that you have a minor accident is 0.22. Probability of a major is 0.03. Stat calc, one variable statistics. So on average, we expect the insurance company to make $640. I probably should write that down. On average, we expect the insurance company to make $640 a policy. So anytime they ask you to compute the expected value, you need to give an explanation of what that is. So that's what we expect. Now we got a standard deviation of 2014.55. And by the way, these should be crossed. That's the standard deviation, and this is the variance. So I take the 2014.55 and I get approximately this value. Once again, we need to know how we showed our work. Showing our work would look something like this. 1,000, not writing. So we'll use another piece of paper. So for your expected value, would be 1,600 times 0.75 plus plus a negative 8,400 times 0.03. That would be work for the expected value. Work for the standard deviation would look something like this. Standard deviation equals square root. Our lowest value is 1,600, so 1,600 minus our expected value. We expected to make, where is it? $640. Squared times its associated probability, 75%, plus plus. Worst case is we lose 8,400. So negative 8,400 minus the 640. That happens, and we square that, and that happens 0.03 times. So that would give us our means and expected values and standard deviation. All right. Now, what we did not talk about, and we should take a look at real quickly for this, is the median. The median occurs as soon as you crest over the 50th percentile. Well, that's 10%. If I add this to it, 0.10 and 0.25, I'm at 0.35, not enough. I go to, so this is at 0. This is at 1, because we're now at 0.35. Now I add 0.3 to it, and I'm at 0.65. That's the first time I get over. So in this case, the median would equal 2. And once again, it's because you have to work with the cumulative probabilities. We have 0, 1, 2, 3. This is at 0.1, 0.25, and 0.30. So this is still 0.1. This now is 0.35 because that's a cumulative. This is a 0.65. As soon as I cross over 50%, that's where my median is. So my median is there. When I look at this one, when I look at this, my median occurs here at the 6 because that's where I first cross over it. Because I can either get a 2, a 4, or a 6. All right. There's no possibility of a 5. I can only get a 2, 4, or 6. So 2, 4, 6, and this is a 0.15. This is a 0.30. This is 0.35. So the cumulative is 0.15. This cumulative is 0.45, not enough. And then all of a sudden we jump all the way up to 0.80. This is the first time we get there. So my median for this would occur at 6. All right. And for the last one, 75% of my 50 percentile is included in the 1600. So my median value would be 1600. Okay, I hope that helps. Thank you.